Welcome back, class. Today I am going to show you how to graph the parent functions of linear, quadratic, absolute value, square root, cubic, and cubed root functions. So let's get started. First off, let's go ahead and graph a linear function. The word linear means line. We're graphing a line. So I'm going to take my values -2, -1, 0, 1, 2, and I'm just going to plug these into my function. The function is f of x equals x. So let's plug these in to y equals x. When x equals -2, y will equal -2. When x equals -1, y will equal -1. When x equals 0, y will equal 0. When x is 1, y will equal 1. When x is 2, y will equal 2. Now that we have our x and y values, let's plot them. We have a point at -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. Now we're going to draw our line. Remember, this is a linear function, so the graph should look like a line. Now let's graph an absolute value function. Our absolute value function is f of x equals the absolute value of x. So the absolute value of x is referring to the distance away from 0. And because we're looking at distance, distance is always positive. So let's plug in -2. When x equals -2, we will get the absolute value of -2, which is just 2. Remember, distance is positive. And I'll go ahead and highlight that so that I remember my y values too. When x equals -1, y will equal the absolute value of -1, which is 1. When x equals 0, we get the absolute value of 0, which is 0. When x equals 1, the absolute value of 1 is 1. When x equals 2, we get the absolute value of 2, which is 2. Now let's take these points and plot them. I have a point at -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Now let's draw our graph. So what does the graph look like? Well, the graph resembles a V. Okay, so for our reminder, let's write that the graph looks like a V. Which means that all absolute value functions will look like V's when you graph them. Let's move on to the quadratic function. Same thing, let's plug the numbers in. We're plugging it into y equals x squared. When x equals -2, y will equal -2 squared, which is 4. When x equals -1, y will equal -1 squared, which is 1. When x equals 0, y will equal 0 squared, which is 0. When x equals 1, y will equal 1 squared, which is 1. When x equals 2, y will equal 2 squared, which is 4. Now let's take these points and plot them. We have a point at -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So I want you to remember that because this is a quadratic function, the graph should look like a U. So reminder, looks like a U. All quadratic functions will look like U's. All absolute value functions will look like V's. Moving on. So now class, let's go ahead and graph the square root function, which is f of x equals the square root of x. And notice how my x values are 0, 1, 4, 9, 16. The reason why I picked these is because these are perfect squares, and we can easily take the square root of a perfect square. And notice how all my x values are positive. That's because if we were to take the square root of a negative number, that's going to give us an imaginary number, which doesn't exist. So now let's take these values and just plug them in. When x equals 0, we get the square root of 0, which is 0. When x equals 1, we get the square root of 1, which is 1. When x equals 4, we get the square root of 4. The square root of 4 is 2. When x equals 9, we get the square root of 9, which is 3. When x equals 16, we get the square root of 16, which is 4. Now we're ready to plot our points. So 0, 0, 1, 1, 4, 2, 9, 3, and we don't have room for 16, 4, so I'll stop at 9, 3. And that's our function. So what my previous students have told me is that the square root function reminds them of a half curve. Let's go with that. All square root functions look like half curves. Now we want to graph a cubic function, which is f of x equals x to the third. So let's plug our numbers in. When x equals -2, y will equal -2 to the third power. Class, that's -2 times -2 times -2, which is -8. And if you want to skip the middle step and go straight to the -8, that's okay. When x equals -1, y will equal -1 to the third, which is -1 times -1 times -1, which is -1. When x equals 0, we'll get 0 to the third. 0 to the third is just 0. When x equals 1, we have 1 to the third, which is 1 times 1 times 1, which is 1. When x equals 2, we'll get 2 to the third, which is 2 times 2 times 2, which gives us 8. Now we're ready to take our points and plot them. We have a point at -2, -8, a point at -1, -1, 0, 0, 1, 1, 2, 8. Now let's draw our curve. So notice how this graph looks like a snake. So for the reminder, we'll put snake. All cubic functions will look like a snake. So now let's look at this cube root function. Our x values are -8, -1, 0, 1, 8. And I know what you're thinking. Mrs. Orca, I thought that we can't take the square root of a negative number. Well, you can't take the square root of a negative number because they'll end up being imaginary. But we can take the cube root of a number because for cube root, you're going to be looking for a group of 3 identical numbers. Let's plug in -8. When x equals -8, we have the cube root of -8. The cube root of -8 is -2. And here's why. So I'll make a note. Cube root of -8. So we have the cube root of, well, what makes -8? That's going to be -2 times -2 times -2. And once again, because we're looking for the cube root, we're going to be looking for a group of 3 identical numbers. Here's our 3. The cube root of -8 is just -2. So let's go back to our table. Now we need to plug in -1. When x equals -1, we have the cube root of -1, which is -1. So when x equals 0, we have the cube root of 0, which is 0. When x equals 1, we have the cube root of 1, which is 1. And when x equals 8, we have the cube root of 8, which is 2. So now let's take all of our points and plot them. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Now let's draw our curve. From what my students have told me is that the cube root function looks like an S. So now let's review everything we learned. So class, these are the 6 parent functions that we've graphed. We have the linear function, which looks like a line. The linear function is f of x equals x. We have our absolute value function, which looks like a v, and the function is f of x equals the absolute value of x. We have our quadratic function. Our quadratic function looks like a u, and that is f of x equals x squared. We also have our square root function, which is f of x equals the square root of x. And remember, that's going to look like a half curve. We have our cubic function, which is f of x equals x to the third, and that's going to look like a snake. And our cube root function, which is f of x equals the cube root of x, and that's going to look like an S. Well, that concludes our lesson. If you liked this video, go ahead and give it a thumbs up, and don't forget to subscribe.